How do electrolytes affect heart function? I can already hear you sighing, but hang in there. In general, electrolytes are substances that help trigger and sustain the heart's electrical impulses. Let's start with what electrolytes are. Electrolytes are substances that produce an electric charge in a solution when dissolved in water. These substances are essential for life because they control and regulate nerve and muscle function, keep us hydrated, regulate our blood pH and blood pressure, but also rebuild damaged tissue, aid in fluid balance, and energy generation. In our bodies, these electrolytes include sodium, potassium, calcium, bicarbonate, magnesium, chloride, and hydrogen phosphate. At times, electrolytes can become imbalanced, which overall throws off the mechanisms of how our body works. The common causes of imbalance are loss of body fluids through prolonged vomiting, diarrhea, sweating, or high fever. The less severe symptoms caused by electrolyte imbalance include twitching, weakness, and seizures. The more extreme ones include hypernatremia, which is too much sodium, hyponatremia, which is too little sodium, hyperkalemia, which is too much potassium, and hypokalemia, which is too little potassium. I bet you thought it was over, but it's not. There's also hypocalcemia, hypercalcemia, hypermagnesemia, and hypomagnesemia. Now, a little background about potassium and the relation to hyperkalemia. Increased extracellular potassium decreases myocardial excitability with the depression of both pacemaking and conducting tissues. That might have been a little overwhelming, so let's break it down. So, the more potassium outside the cell slows the heart rate with the decrease in both pacemaking and contracting tissues. With worsening hyperkalemia, it can lead to cardiac arrest. Now that we've discussed hyperkalemia, let's talk about hypokalemia. Potassium causes myocardial hyperexcitability, just like hyperkalemia, but it has the potential to develop continuing arrhythmias. Got that? Good, let's move on. Hypocalcemia is based off calcium electrolytes. These electrolytes are important because it exerts a positive inotropic effect on the heart. Decreased calcium levels cause decreased myocardial contractions. Hypercalcemia is when there are increased calcium levels, which blocks the conduction of pathways of electrical impulses. Next up, we have hypomagnesemia. This condition relates to the magnesium ions in the heart. Magnesium is required to support the heart's muscles' normal contraction and relaxation. Decreased magnesium levels can cause irregular contractions of the ventricles, leading to arrhythmias. Lastly, we have hypermagnesemia, which is increased magnesium levels that can cause delayed conduction of electrical impulses. That was a lot of conditions, so let's focus on the big one, potassium. Potassium imbalances are more serious than any other electrolyte because they are closely related with cardiac arrhythmia. Cardiac arrhythmia refers to any change in the normal sequence of electrical impulses. With this is a problem because when the heart doesn't beat correctly, it can't pump blood effectively, which in turn will cause the lungs, brain, and all other organs to shut down or become damaged. When potassium levels are too low, they cause stable arrhythmias, but high levels can be fatal. Arrhythmias can also be caused by a delay or blockage in the electrical signal and can occur when the cells malfunction. The electrolytes sodium, potassium, magnesium, and calcium are all involved in heart contraction and relaxation, which all rely on electrical signals. Cardiac contraction starts when calcium ions trigger calcium channels to open. When they open, potassium goes out of the cell and sodium goes into the cell, which causes the heart to contract. Almost directly after, magnesium ions trigger potassium to rush back into the cell, which pushes sodium out of the cell, causing the heart to relax. The rate of contraction is caused by stable levels of electrolytes, which, if thrown off, throws off all bodily function.